Welcome to Baozi Training Leetcode solution. If you want the best mock interview experience in North America, feel free to check us out at baozitraining.org. If you have any questions, feel free to shoot us an email. The email address is on the website, baozitraining@outlook.com. Moreover, feel free to subscribe to our WeChat right here. We're here to help you to nail down your next biggest offer. Okay. So today we're going to talk about this problem called the longest substring without repeating characters. I think it's an interview question from Nest. So essentially, this is like giving you a string, find the length of the longest substring without repeating characters. So for example, this example is ABCY. So let's take a look. Because the longest one without any repeating characters, ABC, so now it's 3. And now because there's A, so you cannot count it ABCA, so it has to be BCA. So, well, essentially all you need to do is return the length of 3. So for example, BBB, all this is actually 1 because every one is the same, so it has to be repeated. So what are the thoughts? So the thought for this problem is more like, using a you can basically just use a hash set in a way that whenever you see a dupe, so you keep 2 pointers. So this is also a 2-pointer problem. So you have a start and an end, right? So it's not when the letters are not the same, is not containing a set, meaning you've never seen this before. So you're just increasing the start pointer. So for example, here, so you have a start is pointing to 0, and then you have your end pointing to 0. So as long as it's not in the set, so your set contains nothing, so you will just increase, and then you check your length is 1. So your current maximal length is pretty much 1. And now your set has A, and now your set has B, your length is 2. Set has C, your length is 3. Now you see a A, because set already contains 1, so you have to delete all the elements until A. So if there's some garbage elements before A, you also have to delete it. So this is basically a ON algorithm, because every node is in and out only once, and ON space. But if you're talking about ON space, essentially it's more like a constant space, because everything is a letter. So you can just use ASCII 256 characters to bound this. Okay. So without further ado, this is just one method. We'll cover another one at the end. So let's do this. Okay. Now, as we said, what we need to do is have a set with character. Okay. So we'll have a start equals to 0, and all we need to do now is right. So we'll have this. So I will assume this whether it's case sensitive or not. So assume all lowercase. Let's just say that. We'll see. Or later on I can cast it. So because the problem did not really say whether it's case sensitive or not. So if this lookup, for example, first of all, if the lookup not contains this character, what we need to do is we need to make sure it contains it, and we need to update the length. So here what we need to do is if it's so we added this one, so to edit one, okay, so this is a not contains part is relatively easy. So now let's see if it contains a character. So when it actually contains a character, so what we need to do is so I think this one can be common one. If it contains this one, what we need to do is what's the easiest way to do this? So I'll need to basically delete through all the characters along the way starting from the start. So basically for the current start, let's do this, let's do a while loop. Now your J is basically finding the one that equals to this char, which also needs to be deleted. So now what is your new start? Okay. So let's just bound it as this won't really. Okay, this should do it. So let's quickly check the logic. So first of all, check, and then you have a lookup, start maximum length. So when it contains this char, so you're starting from your previous start point, and means there must be a dupe. And then you just, as long as it's not equal to this char, you just keep deleting it. you keep deleting this guy from your lookup table, and then increase it as long as you find the one that is equal, and then you also remove this one. Well, and then you make the start equals to I plus 1. Well, do you actually need to remove this one? I don't think so, because you have to add it back. So let's just do not remove it, and then L to just add it. Okay, I think it looks good to me for now. Let's see. Okay, yay. So as you can see, this is a little bit complicated, right? So we can actually make it easier by doing so. The reason I'm saying this is a little bit complicated is because we have to actually remove. So it actually has cost when you remove it from a hash set. Sizing and resizing might happen, and the easy way is actually, if you think about this, if you just simply keep a hash map. So without actually, so whenever you see a dupe, right? So whether it counts or not, the hash map, the key is the character, the value is actually the index, and so whenever you see a duplicate, whether this should be considered or not, you just check whether the current index with it versus your starting point. So if the current index is larger than the starting point, so this one should, if the current index is less than the starting point, so this one is already out of there, so you don't really need to care. So you only need to care is when the current character is larger than your starting point. So then you have to move your starting point to the current one. So I'm not sure if I expressed myself clearly or not, but let's see the idea, okay? This check is going to be the same. And instead of doing a set, we're going to do a map. Okay, and so we'll have a starting point equals to 0, max length also equals to 0, return max length, and what we're going to do is why? Okay. So when it contains, when does it count? And should be larger or equal than start, though this is the part we actually need to do something to reset the start. So now let me think. So when this happens, lookup contains this key and then get this key larger or equal then start. So all the rest of them should be deleted. So your start, the new start location has to become from this key, because you haven't really added anything yet, so this key should not be contained, so it has to be +1. Yes. Has to be +1. You haven't added anything yet, and then you find this one, and then it has to be +1. Yes. And so the length should be calculated the same way. So this pretty much is for if it's not contained. So the length is just keep increasing. So if it contains, it's going to be this. I think this looks much simpler and easy. Wrong answer. Good. AA, so expected should be 1. So I'm outputting 2. So let's see what happens to my AA input. Character lookup, start max. Oh. Never forget to actually add the node. Output is 0. How come output is 0? Input is C. Expected is 1. Input is a C. Char lookup contains. Nope, not contains. So put a C and the index. Oh, my bad. So I guess this part. So contains C. If it not contains, if it is not containing, or if the current C. So we want to actually keep Is this correct? Let me think. So we want to put C all the time, but here we're updating the index, right? Okay, so let's run this example. So I'm outputting 2, so right? Okay, I'm at the char. Lookup contains, first of all, it now contains. So basically start is 0. So I put, so my map currently looks like E index is 0. And then my maximal length at this moment is 0 is 1, right? And now my I equals to 2. Oh, my I equals to 1. It's another E. Lookup contains. Yes, it contains. And then lookup get C is actually, so what is my starting point? Starting point is also 0. So lookup get C is equal to is 0 larger or equal than 0. So now we have to move up the lookup. The starting point is 0 plus 1. Starting point is 1, right? So 1 maximal length. So I is still 1, right? And now my I equals to 2. Lookup still contains, and lookup gets C. Character is larger than start. Oh, here I see the problem. I forgot to. So this should be no matter what. We should just keep updating the index. So if you have a duplicate element or whatever, you always want to keep the latest index in your boundary so that you can always compare. Yeah, that is correct. Well, okay, guys, thanks for watching.